All right, so today we're going to go over how to solve systems by graphing. So we've already done elimination and substitution. So today we're going to do solving systems by graphing. So essentially all I have to do is graph both equations and find out where they intersect. So for our first equation here, y equals 2x, I know my y-intercept, since they don't add or subtract anything to it, would be 0. So I'll put my point at 0, and then I'll use my slope of 2 as a fraction. This would be 2 over 1. So I would rise 2 and run 1. And then this is really, really important for us to get out a straight edge to be able to graph these, because I'm wanting these to be very exact when I graph them, because I'm going to be reading where the two lines intersect. So then looking at my second equation, I'm noticing that it's not solved for y, so it's not in slope-intercept form. So I'm going to have to put it into slope-intercept form first. So to do that, I want to get y by itself. So to get y by itself for the first one, I'm going to subtract 3x from both sides. So I get negative y equals negative 3x plus 5. And then I'm going to divide by the negative 1. So I get y equals 3x minus 5. So now I can graph this like a normal line. So I will graph my y-intercept of negative 5. And then I will use my slope of 3 over 1. So I'll go up 3 and right 1. And so where those two lines cross, that's my point. So that crosses at this point up here. 1, 2, 3, 4, 5. So it's the point 5, 10. So that would be my answer. So for 2, this first equation is already solved for the y-intercept form. Slope-intercept form, so I can graph my y-intercept of 6. And then I use my slope of negative 1, so this means I have to go down 1, right 1. And then draw my line. And then for the second equation, since it's not solved for y, I got to do that first. So I will subtract x from both sides and get negative y equals negative x plus 2. Divide both sides by negative 1. And I get y equals x minus 2. So I'll graph my y-intercept of negative 2. And then my slope is a positive 1. So I'll go up 1, right 1. And then the point where both lines cross is the point 4, 2. So my answer would be 4, 2. For 3, this first equation isn't solved for y, so I'm going to have to do that first before I can graph it. So I'll subtract 4x from both sides. So I get negative 3y equals negative 4x plus 21. And then I'll divide both sides by negative 3. So I get y equals 4/3 x minus 7. So now I can graph my y-intercept of -7. And then I use my slope of 4/3. So I have to go up 4 and right 3. And then use my straight edge to draw my line. So then for the second equation, the y equals x minus 5, I'll graph that y-intercept first of -5. And then my slope is just 1. So I have to go up 1 over 1, right 1. So it looks like our point that they share is the 0.61. So that would be my answer. For 4, the first equation isn't solved for y. So I gotta solve that for y first. So I'll subtract x from both sides. So I get -3y equals -x plus 6. Then we'll divide both sides by -3. So I get y equals now -1 divided by -3 would just be 1/3. And then 6 divided by -3 would give me a -2. So I'll graph the y-intercept first. So I'll go down to -2 and put my point. And then I'll use my slope of 1/3, so I go up 1 over to the right 3. And then for the second line, I'll graph my point of -2, the y-intercept first, and then my slope would be 3 over 1, so I go up 3 over 1. And I'll graph my line. And those two lines look like they intersect at the point 0, -2. So that would be that answer. So to solve systems by graphing, pretty much all we do is just graph both lines and then look to see where they intersect. And that point where they intersect is the answer.